Hello everyone, this is Balu. Welcome to my channel Silkip. Now let us discuss about the previous year questions of AEE, that is 2023 paper regarding strength of materials questions. Coming to the first question, here it is. Which of the following statements are correct for a plane stress isotropic material problem? First of all, you have to understand what is this plane stress condition. Coming to the plane stress condition, if you take a body, it has shear stress acting on it and also normal stress, that is sigma x acting on both sides, and also coming to the sigma y. Here you can count the number of stress components, that is sigma x, sigma y and also tau xy. Total there are 3 stress components. Coming to the major and minor principal stresses, that is sigma 1 comma sigma 3, that is 2 principal components are there. Now let us see the options. 3 stress components can exist at a point. Okay, it is correct only. You can see there are 3 stress components, that is sigma x, sigma y and also tau xy. First option is correct. Next, coming to 6 stress components can exist at a point. It is wrong. Next, coming to the third point, 3 principal stresses can exist at a point. It is also wrong. Next, coming to the fourth option, it is correct. That is 2 principal stresses can exist at a point. If you see the formula for major and minor principal stress also, it is like sigma x plus sigma y by 2 plus or minus root over sigma x minus sigma y by 2 whole square plus tau xy square. Here sigma x, sigma y, tau xy, 3 components are existed. So there is no chance for sigma 1 or sigma 3 to not exist. That means both will exist. So here you can see A and D are the correct options. A and D only. That is option B. Let's get into the second question. Okay. Consider the following sets of derivatives for a prismatic beam, and derivatives of different components like shear force, loading intensity, bending moment, slope are given below. Okay, let us come from the order. You know that y is a deflection. Next, dy by dx is the slope. D square y by dx square is a moment. D cube y by dx cube is nothing but shear force. D power 4 by dx power 4 is nothing but loading intensity. With this you can see the options here. Here you can see dy by dx is nothing but slope, d is nothing but 4. Here you can see both are there. Next you can see A2 is there. Next you have to find between B and C. V is loading intensity, it is nothing but d power 4 y by dx power 4. That is B3 and 2 is the correct option. Okay. You can do in many ways, like you know the basic equation, that is m by ei is equal to d square y by dx square. This is a basic equation. From that also you can get the options. Here m by ei equal to d square y by dx square means m is defined in second derivative. That means suppose p into x is the moment. If you differentiate the moment, then you get the shear force. That means d cube y by dx cube is nothing but shear force. From this logic also you can get into the options. But this is a basic order of all derivatives. Okay. Next, coming to the third question. For an isotropic material, which of the following statements are correct? First you have to understand what is this isotropic. If you consider a body, and in that body if you consider a point, the 3 components of properties are equal in three different directions. This is nothing but the isotropy of the material. Isotropy speaks about only the points in a body, but coming to the homogeneous, it speaks about all points on the body. That means the properties are same at all points throughout the material. That is nothing but homogeneous. If you are speaking about only at a point, then it is nothing but isotropy. Remember this difference. Next, coming to the C, you can see the options. The properties are same at all the points throughout the material. Okay, isotropy is not speaking about all the points, it is speaking about a single point. Next, the properties at a point are same in three different directions. Okay, it is a correct option only. And coming to the third, the property in two directions is same, but it is different in one direction. No, in three different directions, it should be same. That is nothing but isotropy. Next, coming to the fourth option, the properties are same at all the points throughout the material and same properties observed in all three different directions at a point. Okay, it is correct only. In all three different directions at a point, it is same. But coming to the properties are same at all the points throughout the material. Isotropy don't speak about all points. But if you see the options, B is correct and also relatively correct answer is D also. So you can take B and D only as the option. Okay, let us solve this question. Here it is given in the question that match the following for a body under plane stress condition. Let us draw the Mohr circle for plane stress condition. This is nothing but shear. This is normal stress. This is the minor principal stress, that is sigma 1. This is the major principal stress, that is sigma 3. You all know that sigma 1 plus sigma 3 by 2 is equal to sigma x plus sigma y by 2. And also sigma 1 minus sigma 3 by 2 is equal to sigma x minus sigma y by 2. You can see here, distance of the center of the Mohr circle from origin of coordinates. From origin to center of the Mohr circle is asking the distance. It should be equal to sigma 1 plus sigma 3 by 2. Okay, here you can see the option average normal stress. You all know that sigma 1 plus sigma 3 by 2 is sigma x plus sigma y by 2. So you can say A is nothing but 3. The diameter of the Mohr circle. Diameter of the Mohr circle is nothing but sigma 3 minus sigma 1. You can see in this figure, sigma 3 minus sigma 1 give the diameter of the Mohr circle. So that is nothing but difference between the major principal stresses. V is 4. Next, distance of maximum normal stress from the center of Mohr circle. From center of the Mohr circle, he is asking about the distance. It is nothing but radius. Difference between normal stresses divided by 2. Sigma 1 minus sigma 3 by 2 is nothing but the radius. You all know that. So C is nothing but 1. Next, coming to the vertical direction of the Mohr circle. Its vertical direction is nothing but shear stress. That is shear stress 2. A3, B4, C1 and D2. Option 3 is the correct answer. Okay. This is also a simple question you can see here. Coming to the first option, that is vertical load acting at a distance, and this span is, there is no loading here, that is shear force diagram he is asking. If there is no load, you can see there is no shear force diagram here and constant shear force diagram from the load itself. So A should be 2. And coming to the second option, there is a moment acting on it. If there is only moment, the shear force diagram is 0 and you can say B is 3. Coming to the UDL, the shear force diagram should be a triangle, that is C is 4. Coming to the UVL, that is uniformly varying load, it should be equal to parabola, that is the shear force diagram D1. A2, B3, C4 and D1. Third option is the right answer. This is also simple question you can see here. The bending moment, modulus of elasticity and moment of inertia of a beam are given by M, E, I respectively. According to elastic beam theory, You all know the basic equation for elastic beam theory, that is m by I equal to E by R is equal to sigma by Y. Here he is asking about radius of curvature. Remember, R is nothing but radius of curvature. One by R is nothing but curvature. Don't confuse between these two terms. He is asking about R, that is radius of curvature. That means if you take this equation, R is equal to EI by M. This is the correct answer. Next, coming to this question. For plane strain problem, the number of non-zero stress components will be. I already explained you, plane strain means epsilon z is equal to 0. That means we are speaking about strain. So in z direction, whatever the strain components are there, that should be equal to 0. So epsilon z equal to 0. But this will not imply that sigma z to be equal to 0. That means sigma z should not be equal to 0. May be equal to 0, but may not be equal to 0. But it should not imply directly that sigma z is 0. So we have sigma x, sigma y, sigma z, and also tau x. Total 4 stress components are there. The answer is 4. And this is also same type of question. You can see for a beam element, the bending moment, modulus of velocity, moment of inertia, all these are given. What is the flexural rigidity? Flexural rigidity is nothing but EI. Axial rigidity is nothing but AE. And torsional rigidity is nothing but TJ. Remember these terms. Here option is CI. You can see this is the option. And coming to the next question, write the decreasing order with respect to number of stress components for the following case. Decreasing order means highest to lowest. Here for an axially loaded member, there is only one stress component. For plane strain problem, I already explained just now, it is 4 stress components. For plane stress, it is 3. Single point of 3-dimensional structure. For a 3-dimensional structure, there should be 6 stress components. The highest one should be D. D, B, C, A is the correct answer. That is first. For a 3-dimensional problem, the stress components altogether in a tensor of order. You know the order of tensor, that is 3 by 3 matrix is the for tensor. So you can say the order of three-dimensional problem as 3. You can say sigma x, sigma y, sigma z, tau xy, tau xz, and so on. All stress components will be there. This is order of 3 by 3 matrix. For a pure shear problem with shear stress tau xy, what would be the maximum principal stresses? You know the maximum principal stress formula, that is sigma 1 is equal to sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 whole square plus tau xy square. Here he is telling about pure shear. Pure shear means sigma x, sigma y are 0. That means only tau xy will be there. If you solve this one, you will get tau xy. What would be the maximum principal stress? That should be equal to tau xy. Yes. Coming to the other question. For any material, the modulus of velocity at a point can be given by Exy, Ey, and Ez. Which of the following properties is true for a homogeneous material? I already explained you what do you mean by homogeneous. Homogeneous is nothing but if you take a body at all points, the properties should be same. But coming to the isotropy, isotropy speaks about only a single point. If you observe the options here, coming to the fourth option, Ex not equal to Ey not equal to Ez at a point. Okay, at a point this property is there, and the same property exists at all the points throughout the material. This should sync for the homogeneous. That means at a point some properties are there. It may be something X, Y, Z. but this should be same at all points. So you can say that fourth option is the right answer. And coming to this question, what is the critical buckling load for the column shown in the figure? You know that Euler's buckling load is given by pi square EI by LE square, where LE is the effective length of a column. LE is equal to L by 2 because here it is a fixed condition, and also another side also it is a fixed condition. This is a fixed condition, remember this thing. So LE is equal to L by 2, you will get 4 pi square EI by LE L square. Second option is the right answer. Coming to the last question, a prismatic circular bar is situated in the XYZ coordinate system with the length L measured in the X direction. The shear stress at a radius rho from the center and the shear modulus of velocity is G. The polar moment of inertia is K. What is the strain energy? Okay, coming to, if you see the option, while derivating a element and if you derivate the entire equation, you will get the strain energy equation. But he is asking the expression while derived. So if you see here, it is J square and it is also J square. It should not be J square. It should be J only. And he is considering the length. So this is the correct answer you can consider. Okay, thank you for watching this video. If you like the content, please share with your friends and also subscribe my channel. And I will solve the many more problems regarding the AEE